So a very good evening everyone. Just confirm me whether my voice is audible or not. Am I audible to everyone? Just confirm it once. Am I audible? Okay, am I audible to everyone, right? So once again, I welcome you all to the YouTube platform of IMS GATE Academy. Myself Prateek Mishra, and we are conducting this GATE Score Booster series just to help you to revise the complete syllabus before your GATE examination using the numericals. My dear students, I have already conducted 2 sessions on environmental engineering where we have revised the raw water treatment completely and we have seen the wastewater quality parameters. In that we have discussed one of the very important wastewater quality parameter, that is your biochemical oxygen demand. You will see a lot of questions asked from biochemical oxygen demand in your GATE examination. So don't miss any formula for calculating ultimate BOD, BOD 5 or BOD remaining. You may be asked different varieties of question from that area of environmental engineering. Today we will going to see beyond that area. We have very important topics like design of sewers. Next we have treatment of sewage. Then we have disposal of sewage. And we have very important topics of air pollution and solid waste management. Very good evening Richa, a very good evening. Okay, so one by one we will going to take up numericals, and using those numericals I'll try to explain you the concepts as well, so that it will be a help for you to revise this content in very short duration of time. The only cooperation I required from your end is stay tuned till the end of the video, and whatever numericals I am solving here, try to do it as quickly as possible without making any mistake and keeping a check on the units in which you are applying in the formula, right? So just continuing with the previous lecture, we have discussed about biochemical oxygen demand and chemical oxygen demand, COD. So if I just give you a quick recap on that. So if I talk about organic matter is of 2 types. Either it will be a biodegradable organic matter, or it can be a non-biodegradable organic matter. So I have already told you that the amount of oxygen required to decompose only biodegradable organic matter is termed as biochemical oxygen demand, that is your BOD. The total amount of oxygen required to decompose biodegradable and non-biodegradable organic matter is termed as your chemical oxygen demand, COD. The total amount of oxygen required to decompose any type of organic matter present in the system is termed as COD. You have to keep a check. I haven't talked anything about the inorganic matter, right? Everything is about the organic matter. Organic matter is of 2 types, biodegradable and non-biodegradable, and I have defined the value of BOD and COD like this, right? Moving on with this, there are some other parameters as well which are known as theoretical oxygen demand, theoretical oxygen demand is termed as THOD. Now theoretical oxygen demand is the total amount of oxygen required to decompose the biodegradable or non-biodegradable organic matter. Theoretical oxygen demand, as the name says theoretical, it means that if you know the chemical formula for the organic matter, you can write down the oxidation equation, and using the mole concept you can calculate the amount of oxygen required to decompose this organic matter. For example, if I tell you that in your system only methane is present, right? In your system, only methane is present. And I ask you what is the total amount of oxygen required to oxidize this methane. So you will simply write down the oxidation equation for this. So CH4 plus O2 gives us CO2 plus H2O. Just balance this. So this will be 2 times and here it will be 2 times, right? So I am just giving you an idea how to calculate theoretical oxygen demand. 1 mole of methane requires 2 moles of oxygen. 1 mole of methane requires 2 moles of oxygen. 1 mole of methane requires 2 moles of oxygen. It means that what is the molecular weight of methane? The molecular weight of methane will be carbon is 12, hydrogen is 1. So 12 plus 4 will be 16. So 16 gram of methane requires, so oxygen is 16, 16 into 2 is 32, 32 into 2 is 64, requires 64 grams of oxygen, right? So X grams of methane, CH4 requires 64 by 16 into X grams of oxygen. Now this quantity that you have calculated is known as theoretical oxygen demand, THOD. How you can calculate this quantity? Only if you know the exact chemical formula for the organic matter present in the system. So if you know the chemical formula, you can write down the oxidation equation and you can calculate the theoretical oxygen demand, right? So theoretical oxygen demand can be only calculated for those organic matter for which we know the chemical formula for the organic matter and we know the concentration of the organic matter, right? So this is your next wastewater quality parameter. Next wastewater quality parameter is your total organic carbon, which is TOC. Total organic carbon, again TOC. So this is another way of representing the amount of organic matter present in the system. In TOC, we represent the organic matter in terms of carbon content. Again, for calculating the value of TOC, you should know the chemical formula for TOC, for the organic matter. If I say there is one organic matter which is C6H12O6 present in your system, right? This is termed as glucose. If I say glucose is present in your wastewater, and I know the chemical formula of glucose and I also know the concentration of glucose. Say the concentration of glucose is X milligram per liter. And then in the question, it is asked to calculate the TOC concentration or the total organic carbon concentration. So how to proceed with this? You can just observe this chemical formula and you will realize that 1 mole of glucose contains 6 moles of carbon. So you proceed like this: 1 mole of glucose, 1 mole of glucose contains 6 moles of carbon. 1 mole of glucose contains 6 moles of carbon. Now just calculate the molecular weight of glucose. So this is carbon 12 into 6 plus hydrogen is 12. So 1 into 12. Oxygen is again 16 into 6. 16 into 6. And this will going to give you the total molecular weight of glucose. This much amount or this much gram of glucose contains 6 into 12 grams of carbon. Please calculate this and tell me the value. What will be the molecular weight of glucose? Just tell me, calculate this and tell me the value. Please calculate this and tell me the value. This is 12 into 6, 72 plus 12 plus 16 into 6. So this will be your 180 gram of glucose. 180 gram of glucose contains, this is 6 12s are 72 gram of carbon. Then X gram of glucose contains 72 by 180 into X gram of carbon. Now this quantity that you have calculated is known as total organic carbon, TOC, right? So theoretical oxygen demand and total organic carbon are first of all dependent on which type of organic matter is present. If you want to calculate TOC and theoretical oxygen demand, you should know the exact chemical formula and you should also know the concentration of the organic matter. Then only you can calculate this quantity, right? Now talking about the comparative study, that this should you keep as a note point because a statement can be framed from it. So the highest value will be THOD. Now this THOD will be greater than equal to COD, and this COD can be greater than or equal to BOD, which is greater than TOC. TOC will be always the last thing, right? So this is the relation you should keep a check in your mind, right? You should keep a check, right? Chalo, this was some of the things that were left from the previous session. Now moving ahead in the session, I would like to make few announcements. First of all, my dear students, if you want to get the regular updates of all the PSU job notifications, you can join our Telegram group. The link is given here and it is also there in the description box. If you want to enjoy the regular quizzes on the daily basis, then again, they will be available in our Telegram group. You will get our YouTube schedule in our Telegram group. So our Telegram group is benefiting you to revise the content. It is also helping you to practice your technical subjects through daily quizzes, right? Next, at IMS GATE Academy, we offer you different types of courses. In all these types of courses, we provide you with around 800 hours of live content with interaction. We provide you with 30 plus years of GATE question bank, and we provide you with theory and exercise book which are more than 30 plus in numbers. Next, we provide you with 12 personalized one-to-one mentoring sessions. Along with this, we provide you with 130 plus test, and which includes chapter test, subject test, multiple subject test, advanced subject test, and the full length mock test with the video solution. Chalo, so with this, we will going to continue with our session. So here is some of the things which are related to the design of sievers. First of all, my dear student, siever is designed for to carry maximum hourly discharge. Sievers are designed to carry the maximum hourly discharge, but they are checked for the development of self-cleansing velocity during their minimum hourly discharge. The value of self-cleansing velocity can be calculated as under root 8 K by F, G minus 1 into GD, right? Then we have the hydraulic properties of flow inside the siever. So those are depth of flow, small d by d is equal to 1 minus cos alpha by 2. Then you have perimeter of flow, which is small p by p, which is alpha by 360 degree. Area of flow is small a by a, which is alpha by 360 minus sine alpha by 2 pi. Next you have this. the hydraulic mean depth small r by capital R is equals to alpha by 360 minus sine alpha by 2 pi divided by alpha by 360. Last you have velocity of flow small v by v is equals to alpha by 360 minus sine alpha by 2 pi divided by alpha by 360 whole raised to the power 2 by 3. For the sievers having same degree of self-cleansing, their velocity of flow at partial depth and at full depth is equal to r by capital R raised to the power 1 by 6. Just keep these formulas in mind and try to solve this question. I'll give you 3 minutes of time. Go for it. Please do it. Thank you so much, Vipin sir. Thank you so much. Okay, everyone, go for it. Go for it. Just tell me your answers. So let's see this question. The question is saying, question says that a siever of 400 mm diameter and slope 1 in 800 running half full has a flow velocity of 1.64 meter per second. What velocity of flow will be obtained if the slope is made to 1 is to 200? So the slope of the siever is changed, right? So this was my siever. Okay. This is my siever and this siever is running half full. This siever is running half full like this. This is the siever which is running half full. The diameter of the siever is given to you as 400 mm. So depth of flow small d is equal to 200 mm. This is your depth of flow, right? This is 200 mm, right? First of all, if you want to calculate the hydraulic mean depth, so hydraulic mean depth is equal to wetted area divided by wetted perimeter. Now wetted area is half of pi by 4 into d square. Half of pi by 4 into d square. This is your wetted area divided by your wetted perimeter. So wetted perimeter is half of pi d. Half of pi d. And d is again 400 mm. So this pi and this pi cancels out, this half and this half cancels out. You have 400 by 4. 400 by 4 as your hydraulic mean depth, which is 100, right? But this hydraulic mean depth is not changing, only your slope is changing. So your flow velocity is given by Manning's equation. So I will write down by Manning's equation. By Manning's equation, flow velocity V is equals to 1 by N into R raised to the power 2 by 3 into S raised to the power 1 by 2, right? In first condition, your V1 is equal to 1 upon N into R raised to the power 2 by 3 into S1 raised to the power 1 by 2, right? When the slope is changed, the hydraulic mean depth will not change. Reason is the depth of flow is not changing. So I will write down V2 velocity is equals to 1 upon N into R raised to the power 2 by 3 into S2 raised to the power 1 by 2, right? You can just take the ratio of these two quantities, substitute the value of S1 and S2, substitute the value of V1 to get the value of V2. Other terms will going to cancel out. This 1 by N and 1 by N will cancel out. This R and this R will going to cancel out. So you have the ratio of V1 by V2 is equal to S1 by S2 raised to the power 1 by 2. Okay, just substitute the value. V1 is given to you as how much? V1 is 1.64 meter per second. So this is 1.64 divided by V2. S1 is given to you as how much? S1 is 1 in 800 and S2 is 1 in 200. So this is 1 by 800 divided by 1 by 200 raised to the power 1 by 2, right? From here you can calculate the value of V2. Chalo, let's do this. So this is 1.64 divided by V2 is equal to, this will be 200 by 800, so this will be 1 by 4 raised to the power 1 by 2, right? So the square root of 1 by 4 will be 1 by 2 and you have to just multiply 2 here. So V2 will be 2 into 1.64. So 2 into 1.64 will be 82.5, sorry. This will be 3.28 meter per second. This is the value of V2 that was asked in the question. So this is how you need to proceed with this question, right? I hope you have seen the solution and you have also got the answer also. Chalo, moving on to the next question, try this one. The question says that in a circular sieve of diameter D, if the depth of flow is D by 4, then the wetted perimeter will be. The depth of flow is D by 4. You observe this. This is my sieve. For this sieve, the diameter is capital D. The depth of flow is D by 4. Means this is the depth of flow. And this depth of flow is given to you as D by 4. This is your depth of flow. And this depth of flow is given to you as D by 4. This is your depth of flow. And D is given to you as D by 4. Right? You need to calculate the wetted perimeter. How you can do this? For calculating the wetted perimeter, you need to first calculate this angle, central angle. You need to first calculate this central angle alpha. Using that central angle, you can calculate this wetted perimeter, right? Now, how to get this wetted perimeter? Can you tell me? So, you have this ratio of small d by capital D. This is 1 minus cos alpha by 2 whole divided by 2. You can check this formula also. The ratio of small d by capital D is equal to 1 minus cos alpha by 2 divided by 2. From here you can get the value of alpha, and using that alpha you can calculate the value of wetted perimeter. So substitute the value. This small d is given to you as d by 4. So d by 4 divided by d is equal to 1 minus cos alpha by 2 divided by 2. From here get the value of alpha. This d and this d will going to cancel out. This 2 and this will be 1 by 2 is equal to 1 minus cos alpha by 2. So cos alpha by 2 comes out to be 1 by 2. So from here the value of alpha comes out as 60 degree. The value of alpha comes out as 60 degree. The value of alpha is 60 degree. Please do this. Sorry, the value of alpha by 2 will be 60 degree. The value of alpha will be 120 degree. The value of alpha will be 120 degree, right? Once you know this value of alpha, you can calculate the wetted perimeter. So wetted perimeter small p by total perimeter capital P is equal to alpha by 360. So wetted perimeter small p is equal to alpha is 120, 120 by 360 into pi d. Just calculate this. This is 1 times, this is 3 times. So wetted perimeter P, small p, comes out to be pi d by 3. This is your wetted perimeter. Wetted perimeter small p comes out to be pi d by 3, right? So whenever you have a question from design of sievers, it is most likely that you can get a question from the hydraulic properties of the siever. So this is how you need to proceed. Chalo, let's move on to the next question. Try this one. It's a good question. I'll give you 3 minutes of time. Just go for it. Please go for it. Try this question. Please do it. It's a good question. Go for it. Go for it. The question is saying that the sewer has a diameter of 400 mm and slope of 1 in 600. While running full, it has a mean velocity of 0.9 meter per second. If both the diameter and the slope are doubled to the respectively 800 mm and 1 in 300, what will be the change mean velocity while running half full? So two situations are given to you and you have to analyze this sewer on these two situations. The first situation is sewer has a diameter of 400 mm and the slope provided is 1 in 600 and this is running full, right? So let me draw this diagram first. So this sewer is running full. This is your sewer which is running full. The depth of flow is equal to the diameter of the sewer. Okay. So D is equal to diameter of the sewer and the diameter of the sewer is given to you as 400 mm. Okay. This is my case 1. Observe this. Now for this, I need to calculate the hydraulic mean depth if I want to know the velocity. So hydraulic mean depth small r is equal to wetted area by wetted perimeter. Wetted area is pi d square by 4. Wetted perimeter is pi d. So this will be d by 4. This is your hydraulic mean depth. So r from here I'll get as 400 by 4. So hydraulic mean depth comes out as 100 mm. Okay. Next, a slope is also given to you. A slope is given as 1 in 600 and for which the velocity is 0.9 meter per second. A slope is 1 in 600 and the velocity v is given to you as how much? This is 0.9 meter per second. Right. Now the diameter and the slope is doubled. Let's check on this. So diameter of the sewer is doubled. This is the double diameter. Now the value of d dash, is 800 mm. But this sewer is running half full. So the depth of flow, small d dash in this case is again 400 mm. Right? This sewer is running half full. Now what you have to do is, for this half full running depth, you need to calculate the hydraulic mean depth. R dash will be equal to half of pi by 4 into d dash square divided by half of pi d dash, right? So from here also you will get hydraulic mean depth R dash is equal to d dash by 4. You will get R dash is equal to d dash by 4. So d dash is 800 mm. So 800 by 4 will be equal to 200 mm. So this is your hydraulic mean depth for this sewer. For this sewer, the slope is also doubled. So the value of S dash is given to you as 1 in 300. This is the slope, 1 in 300. Right? And you need to calculate the velocity V dash for this sewer. Now how to go for it? We know that this velocity of flow can be calculated using Manning's equation. So by Manning's equation, I can write that by Manning's equation, or I should write here, by Manning's equation, first, for this case, if I have to write down V, I will write down V as V is equals to 1 upon N into r raised to the power 2 by 3 into s raised to the power 1 by 2. Okay. If I have to write velocity of flow for the second case, so v dash is equal to 1 upon n into r dash raised to the power 2 by 3 into s dash raised to the power 1 by 2. Now you will say, sir, you have written r dash, you have written s dash, but you haven't written n dash. My dear student, n is known as the Manning's roughness coefficient, and n will not change until and unless the material of the sieve is not changing. In the question, there is nothing mentioned about the change of material. That's why the value of Manning's roughness coefficient I have considered as equal in both the cases. So you have to just take the ratio of these two values to get the value of v dash. So this 1 by n and 1 by n will cancel out. Substitute all the values. So v is given to you as how much? V is 0.9 meter per second. This is 0.9. V dash I need to calculate. Then you have r by r dash. So r you have calculated as 100 mm and r dash is 200 mm. So this is 100 divided by 200 raised to the power 2 by 3. Then you have the slopes. So first slope is 1 in 600 and second slope is 1 in 300 raised to the power 1 by 2. You have to just solve this to get the value of v dash. Jalo, do this and tell me the answer for this. So this will be how much? This will be 1 by 2 raised to the power 2 by 3. So I will write down v dash is equal to 0.9 divided by 1 by 2 raised to the power 2 by 3 into 1 by 2 raised to the power 1 by 2. Okay, you can just add these two also. So this will be v dash 0.9 divided by, so this will be 1 by 2 raised to the power 2 by 3 plus 1 by 2. So this will be how much? 4 plus 3, 7. So 0.9 divided by 1 by 2 raised to the power 7 by 6. Do this calculation. So this will be 2.02. V dash will be 2.02 meter per second. This is the value of V dash, right? So this is how you need to tackle these type of questions where data related to more than 2 sievers are given to you. Okay, chalo move to the next question. Try this one. Okay, so these are the questions related to the design of sievers, my dear students. Once you have designed the siever, okay, all this wastewater is collected. Okay, now this I haven't told you. Once the water is supplied into the community, after different usages in the community is converted into wastewater. The collection of this wastewater, transportation of this wastewater, quality analysis of this wastewater, treatment of this wastewater and disposing this wastewater back to the source. This entire process is classified as wastewater engineering. Once the water is collected from the community, it is taken into the sewage treatment plant. Now the amount of treatment given to this wastewater depends on two things. The degree of treatment given to the sewage or wastewater depends on two things. First one is the existing quality of the sewage and second one is the self-purification capacity of the source where this sewage has to be disposed. So the degree of treatment given to sewage depends on the existing quality of the sewage and the self-purification capacity of the source where this treated sewage has to be disposed. Now when we talk about the treatment of sewage, it is given in 3 stages. First one is known as the preliminary treatment. So in preliminary treatment, basically we remove the coarse suspended solids and the inorganic suspended solids present in the wastewater. In preliminary treatment, we have the removal of coarse suspended solids through the use of screens. Then we have the grit chamber, which removes the inorganic suspended solids present in the wastewater. We have also the skimming tanks. These skimming tanks are not used in our country, it is used in foreign countries. Skimming tanks is responsible for the removal of oil and grease from your wastewater, right? After the preliminary treatment, where all the coarse suspended solids are removed and the inorganic suspended solids are removed, you have the primary treatment. The primary treatment is done using primary sedimentation tank, and primary treatment is responsible for the removal of suspended organic solids, right? So primary treatment removes all the organic suspended solids present in your wastewater. Now after primary treatment, in the wastewater there is only dissolved organic matter present, or dissolved organic solids are present. Now these dissolved organic solids from the wastewater are removed using the secondary treatment, or known as biological treatment. In this biological treatment, everything is taken care by the different types of microorganisms. Those can be aerobic microorganisms or anaerobic microorganisms, carrying out the decomposition either in the presence of oxygen or in the absence of oxygen respectively. If there are aerobic organisms, then these aerobic organisms will carry out the decomposition in the presence of oxygen, right? So this biological treatment can be either of two types, aerobic system and the anaerobic system. In this secondary treatment, all the dissolved organic matter will be removed from the wastewater. Now, this grit chamber which is present here, primary treatment, that is your primary sedimentation tank, and the secondary sedimentation tank present in the secondary treatment, all these three treatments will produce the sludge. Out of this sludge, this secondary sludge is highly stable sludge, right? Means the sludge which is obtained after secondary treatment can be also used as a manure directly in the field. It will not create any unhealthy situation where it is disposed. Similarly, where the sludge which is obtained from the grit chamber, it contains inorganic suspended solids, and wherever inorganic suspended solids are present, it will again not create any unhygienic situation. The sludge obtained from the grit chamber can be used for filling purposes, right? So the sludge from the grit chamber and the sludge from secondary sedimentation tank is not a problem. But the sludge obtained from the primary treatment or the primary sedimentation tank contains huge amount of undecomposed organic matter or non-decomposed organic matter. Now, if this sludge from the primary sedimentation tank is disposed directly into the field, huge amount of microorganisms will going to attack the organic matter present in the sludge, and which creates the unhygienic situation around this sludge, right? So the sludge obtained from the primary sedimentation tank requires extra treatment, and that treatment is given in the sludge digestion tank, where the sludge obtained after the primary sedimentation tank is digested in the sludge digester, and this is totally an anaerobic process. The sludge obtained from the primary sedimentation tank is taken to the sludge digester, where it is acted upon by the acid formers and the methane formers, and they carry out the digestion of this raw sludge. After digestion of the raw sludge, we have the digested sludge and the supernatant liquid. This supernatant liquid is again recirculated back in the primary sedimentation tank. Okay, so this is just an overview about the treatment of sewage. I hope you have learnt all of this. When we talk about the settling tanks, my dear students, the process of sedimentation, where the particle is settling under its own weight, we have four different types of settling. First one is type 1 or discrete particle settling, where the particle settles under their own weight and there is no influence of the other particle in the settling of this particle. Even the size of the particle does not change while the particle is settling. This type of settling is observed in the grit chamber and the plain sedimentation tank of the raw water treatment. Second, you have type 2 or flocculent settling. Now this settling we get, or this type of settling we observe in the primary sedimentation tank or the sedimentation tank after coagulation or flocculation. The reason is, in this flocculent settling, what we observe is that the size of the particle increases over the period of time, and in this type of settling, the formula that we use to calculate the settling velocity cannot be used. The third type of settling is known as zone settling. Now, this type of settling is observed in the secondary sedimentation tank after the activated sludge process, right? The particles which are settling is influenced by the settling of other particles. The velocity field going to overlap and they will going to settle in the form of zone. So, these type of settling are known as zone settling. The last and the fourth type of settling is known as the compression settling. This type of settling is observed in the secondary sedimentation tank after the trickling filters. In this type of settling, huge amount of suspended solid concentration is present such that the lower layer of settling particles supports the upper layer and the upper layer of the settling particle compresses the lower layer, which squeezes out the water present in the voids. That's why this type of settling is known as the compression settling. So these are the four types of settling. You should remember in which tank which type of settling is taking place, right? Chalo, moving on with this. Next, you have this question from grit chamber. I'll give you 3 minutes of time. Just go for this. It's a very good question from grit chamber. So I'll tell you one more thing. In the gate examination, if you get a question in which so much data is given, I'll tell you it will be one of the easiest question. You have to just figure out which data to be used. Just go for it. Please do it and tell me the answer. Let's see this. The question is saying that a grit chamber of rectangular cross section is to be designed to remove particles with the diameter of 0.25 mm and specific gravity of 2.7. The terminal settling velocity of the particle is estimated as 2.5 centimeter per second. The chamber is having a width of 0.5 meter and has to carry a peak wastewater discharge of 9720 meter cube per day, giving the depth of flow as 0.75 meter. If a flow through velocity of 0.3 meter per second has to be maintained using the proportional wear at the outlet end of the chamber, the minimum length of the chamber in meter is. You need to find out the minimum length of the chamber to remove 0.25 mm size of the particle, right? Now, this is just a question which is one of the great example of a easy question framed in a very complicated way, okay? Now, let me show you what is the story saying. This is my grid chamber, okay? This is my grid chamber. The length of the grid chamber I have to calculate. This length I have to calculate, right? Observe this very carefully, very carefully. I have to calculate this length, L. The height or the depth of flow is given to us. This height or depth of flow is given to us. So, this is my particle, or this is the particle, which is moving with velocity of flow Vf, and it will going to settle with the settling velocity Vs, right? The detention time available with this particle for which this tank is designed is Td, and in this Td time, the particle which is entering at this end will going to settle at this end, like this. It will going to settle at this end, okay? The particle which is entering at this end inside the grid chamber will going to settle at this end. You need to calculate the length of flow. Now, first of all, tell me, if Td is the available time with the particle, then in this Td time, the particle is traveling this vertical distance. So, time taken to travel this vertical distance is equal to depth of flow divided by Vs. This is also equal to time taken by the particle to cover this length L, and the time taken by the particle to cover this length L is L by Vf, okay. I know the depth of flow, I know the velocity of flow. Let me also check whether settling velocity is given to you or not, okay. So, a grid chamber of rectangular cross section is to be designed to remove particles with diameter of 0.25 mm, specific gravity of 2.7. The terminal settling velocity of the particle is estimated as 2.5 centimeter per second. So, the settling velocity is also given to us. The chamber is having a width of 0.5 meter and has to carry the peak wastewater flow of 9720 meter cube per day, having depth of flow of 0.75. So, let me write down all the data. The terminal settling velocity is 2.5 centimeter per second. Vs is 2.5 centimeter per second. So, if I have to convert this into meter, this will be 0.025 meter per second. Next, your depth of flow H is given to you as how much? Depth of flow is given as 0.75 meter. Next, the velocity of flow is also given to you as flow through velocity is 0.3 meter per second. So, velocity of flow Vf is 0.3 meter per second. Now, just substitute all these values and calculate the length. Detention time available with the particle to move down by the amount of H and move by the amount of L is same. Substitute all the values. So, H is equal to 0.75, Vs is 0.025, L I need to calculate, and Vf is given to you as 0.3. Using one simple relation, you can calculate the length, right? It was a 2-mark question asked in your examination. Just check for this. So, this will be 0.75 divided by 0.025 into 3. (0.75) divided by 0.025 So length will come out as 90 meters. Length of the tank will be 90 meters. Okay, so this is how you need to deal with this question. Chalo. So I hope this explanation is clear to you. Let's move on to the another question. Try this one. Again 3 minutes of time to you. Go for it. Go for it. This is 0.3, so this will be not 90, 9 meters. Length will be 9 meters. Try this question. Please keep commenting your answers. Go for it, go for it. So let's see this. The question says that the spherical grid particles having radius of 0.01 mm and specific gravity of 3 needs to be separated in a settling chamber. It is given that G is 9.81 meter per second square. The density of the liquid in the settling chamber is 1000 kg per meter cube. The kinematic viscosity of the liquid in the settling chamber is 10 raised power minus 6 meter square per second. Assuming the laminar conditions, the settling velocity in mm per second up to 1 decimal place is. So you need to calculate the settling velocity of the particle for laminar flow condition. So before that, we just write down all the data. So radius is 0.01 mm. Radius of the particle is, so given data is, radius is 0.01 mm. So the diameter of the particle will be 0.02 mm. Next, specific gravity G is given to you as 3. Then kinematic viscosity is given to you as 10 into 10 raised power minus 6 meter square per second. This is your kinematic viscosity, right? G is also given to you, everything, and you need to calculate the settling velocity. Now you observe this. For laminar flow condition, settling velocity Vs is equal to 1 upon 18 gamma W d square into G minus 1 by mu. Now here the mu is coefficient of dynamic viscosity. But in this question, this mu is not given to you. Instead of mu, kinematic viscosity is given to you. Now observe this. this gamma W can be written as, so Vs is 1 upon 18. This gamma W is equal to rho W into G into D square into G minus 1 divided by mu. Now this mu into rho, mu divided by rho, this is your kinematic viscosity. So you have one more formula for settling velocity. So Vs is equal to 1 upon 18 G into D square into G minus 1 divided by nu, right? Now using this formula, you can calculate the settling velocity. Just substitute all the values. Please keep a check in the units, in which unit you are substituting the values. So Vs is equal to 1 upon 18. G is 9.81 meter per second square. Diameter is 0.02 mm. So I will write this as 0.02 into 10 raised power minus 3 the whole square. G minus 1 is 3 minus 1 divided by nu, which is given as 10 raised power minus 6 meter square per second, right? So from here you will get the settling velocity in meter per second, but in the answer we want it in mm per second. So first you calculate this. So you have Vs is equal to 1 upon 18. This will be into 9.81 into 0.02 the whole square into 2, right? This 10 raised power minus 6 and this 10 raised power minus 6 will cancel out. So here you will get the answer in meter per second. But you want the answer in mm per second, so you need to multiply it by 1000. So Vs is equal to 1 upon 18 into 9.81 into 0.02 the whole square into 2 into 1000. This will be the answer in mm per second. Solve this. So this will be So this will be 0.436 mm per second. So settling velocity Vs will be 0.436 mm per second. This is the settling velocity by which the particle will going to settle, right? So this is how you need to proceed with this question. Whenever the kinematic viscosity is given to you, make sure you use this formula. Whenever dynamic viscosity is given to you, you can use this formula. But this formula is only applicable for laminar flow condition. Please keep a check on this, right? It is not applicable for transition flow or turbulent flow. It is only for laminar flow condition, right? So I hope you have understood this question. Chalo, let's move on to the next question. This is, so these two questions were there, or these questions were there from your grit chambers or the sedimentation mechanism, right? Next, my dear students, I have already told you that biological treatment is all about removing the dissolved organic matter by using the microorganisms, right? The biological treatment can be either of two types. It can be aerobic process or it can be anaerobic process. So we have different types of biological treatment units. In that we include trickling filters, we have rotatory biological contractors, we have activated sludge process, we have upflow anaerobic sludge blanket reactor, we have septic tank, and then we have the IMOF tank, we have the oxidation pond. So out of all these, we give only one. So if I talk about biological treatment units, the first one is your trickling filter. Second one is your rotatory biological contractor, RBC. Third one is your activated sludge process. Then you have upflow, anaerobic, sludge blanket reactor. Then you have next septic tank, next sixth one is your IMOF tank, next seventh one is your oxidation pond. Now there can be a statement which type of mechanism it is or which type of biological treatment unit it is. So if I talk about trickling filter, trickling filters are aerobic. Here the oxidation or the decomposition of the organic matter takes place in the presence of oxygen. So this is aerobic. Rotatory biological contractor is also aerobic. Activated sludge process is also aerobic. Upflow anaerobic sludge blanket reactor, in its name itself you have anaerobic. So this is anaerobic. Then you have the septic tank and IMOF tank. Both are anaerobic. This is also anaerobic and this is also anaerobic. And last you have the oxidation pond, which is aerobic. Okay. So aerobic and anaerobic biological treatment units are classified based on the category or based on the process that whether the oxygen is available or not. Sir, I am not preparing for GATE, but I am in grade 10 preparing for board. Okay. Mr. Feedback, in your name itself it's a feedback, right? So better correct your name and then I'll give you a feedback on how to increase your memory technique. Chalo. So I was talking about these biological treatment units. In these biological treatment units, if the decomposition is taking place either in the presence of oxygen or in the absence of oxygen, based on this, these mechanisms are defined as aerobic and anaerobic treatment units, right? So this is the list of aerobic and anaerobic. Now, how we are bringing the microorganism in contact with the organic matter to carry out the decomposition, based on that, the system can be classified as attached growth system or the suspended growth system. Just for your quick knowledge, trickling filter is your aerobic attached growth system. This is aerobic attached growth system. Then you have this RBC, rotatory biological contractor. This is also aerobic attached growth system. Next you have the activated sludge process. It's a aerobic suspended growth system. This is your aerobic suspended growth system. This is your aerobic suspended growth system. Next you have the upflow anaerobic sludge blanket reactor. It's an anaerobic, again suspended growth system. Your septic tank and IMOF tank are also anaerobic suspended growth system. And this is also suspended growth system, anaerobic. Your oxidation pond is your aerobic, again suspended growth system. So you can expect a multiple select question can be framed from this information, which type of system it is, whether it's a aerobic system, suspended or attached growth system. So you need to keep a check in all the biological treatment units and which type of system it is. Okay. Now out of these biological treatment units, we provide one biological treatment unit for treating the wastewater. Okay. So first one, we have the trickling filters. We have two types of trickling filter, standard rate trickling filter and the two-stage high rate trickling filter. In trickling filter, the most important formula is about their efficiency. So efficiency of standard rate trickling filter is equal to 100 upon 1 plus 0.0044 under root u, where u is the organic loading rate in kg per hectare meter per day. Next, you have the two-stage high rate trickling filter, and these are the formulas for it. Now you go for this question. This is for your standard rate trickling filter. Just go for it. You have 3 minutes of time. Just go for it. So go for it. Go for it. Go for it. Let's see this question. The question says that the standard rate trickling filter, is designed for the organic loading rate of 0.175 gram per meter cube per day. So organic loading rate U is given to you as 0.175 gram per meter cube per day. If the influent BOD of the sewage is 150 milligram per liter, then the effluent BOD of the sewage that is coming out from the trickling filter is. So process is very simple. Here you are given with one trickling filter mechanism. The wastewater is entering from this end and it is coming out from this end, right? The wastewater which is entering has a influent BOD of 150 milligram per liter. And this trickling filter is responsible to remove the BOD, right? There will be some efficiency of BOD removal, okay? So if I know the efficiency of BOD removal for this trickling filter, I can calculate how much amount of BOD will be coming out. So BOD will be, that is coming out S, is equal to 1 minus efficiency of BOD removal into S naught. This is the amount of BOD that will be coming out. Now, for this trickling filter, I need to calculate the efficiency. For this efficiency, there is one formula which is 100 upon 1 plus 0.0044 under root U. So efficiency of trickling filter under root U, where U is the organic loading rate in kg per hectare meter per day, right? So you need to keep a check in which unit you need to substitute the value of U to calculate the efficiency of the trickling filter. Here the organic loading rate is given to you in gram per meter square per day. So you need to convert this into kg per hectare meter per day, and then you calculate the efficiency. So U is 0.175 gram per meter cube per day. So this is equal to 0.175 into 10 raised power minus 3 kg divided by, this is meter square into meter. So meter square converted into meter will be 10 raised power minus 4 hectare. Meter square converted into hectare will be 10 raised power minus 4 hectare into meter per day, right? So this will be how much? This will be 1.75 kg per hectare meter per day, right? Now you have the organic loading rate U, you can calculate the efficiency of the trickling filter. So efficiency of trickling filter is equal to 100 upon 1 plus 0.0044 under root U. Substitute the value, so this is 100 upon 1 plus 0.0044 under root U, which is 1.75. This will be your efficiency of trickling filter. Just go for it. Tell me the value for this. So this will be 99.42. Efficiency of trickling filter comes out to be 99.42. This is your efficiency of your trickling filter. Now this much amount of BOD will be removed. So BOD entering is equal to 150 milligram per liter. BOD that will be coming out is equal to 150 into 1 minus efficiency of trickling filter. So this is your BOD coming out, right? Substitute the value. So this is 150 into 1 minus 0.9942. This will be your BOD coming out. So 1 minus 0.9942 into 150. So 0.87 milligram per liter of BOD will be coming out. This is the amount of BOD that will be coming out from the trickling filter. Okay, and this will be my final answer. So whenever you get a question from, especially from the standard rate trickling filter, you have to make sure that what is asked, and based on that you need to calculate all the values. Chalo, moving on with this. So next is your activated sludge process. Now in the activated sludge process, the most important areas are these basic definitions. So you have hydraulic retention time, HRT, is equals to volume of the aeration tank divided by the discharge Q naught. Next you have the organic loading rate, OLR, which is equal to Q naught S naught divided by the volume of the aeration tank. You have specific food utilization rate, U, which is equal to Q naught into S naught minus S divided by V into X. Then you have the sludges, theta C is equals to V into X divided by QW into XU. Next you have food to microorganism ratio, which is equal to Q naught S naught divided by V into X. And next you have this equation of activated sludge process, which is 1 upon theta C plus KER is equals to U into Y. Theta C is your sludge age, U is the specific food utilization rate, and Y is the fraction of organic matter converted into biomass. Next, chalo, let's have this question, try this question. Go for this. Go for it, try this question. let's see this. The question is saying that in an activated sludge process, the influent discharge for aeration tank Q0 is 47 mld with inlet BOD concentration of 300 milligram per liter. The BOD removal efficiency of the aeration tank is 96%. The volume of the aeration tank is 380 meter cube with MLSS concentration of 890 milligram per liter. Then what is the specific food utilization rate for the above activated sludge process? Now let's see this. First of all, you understand the diagram. Whenever you get a question from activated sludge process, always go with the diagram. It will be easy to analyze what is actually asked in the question. So So this is the amount Q0 of discharge which is entering into the aeration tank. Q0 amount of discharge is entering into the aeration tank with a BOD of S0, right? For this aeration tank, volume is V. This is my aeration tank for the activated sludge process. Volume is V and MLSS concentration is X, right? Inside this aeration tank, the organic matter will going to decompose and the BOD will reduce from S0 to S. So S is the amount of BOD inside the aeration tank after the aeration tank has carried out the decomposition of the organic matter. So the discharge that will be coming out of this aeration tank will be equal to Q0 plus QR. The amount of discharge that will be coming out from this tank will be Q0 plus QR. BOD concentration will be S. QR discharge is the recirculated discharge, right? Now, from here, you have QU amount of discharge that is extracted from this secondary sedimentation tank, and this is the Q0 amount of discharge that will be moving out, or you say QE amount of discharge that will be moving out, QE, right? Out of this QU, QR amount of recirculated and QW amount of discharge is your wasted sludge discharge. Again, your BOD concentration in this effluent, here in the recirculated discharge, wasted sludge discharge, BOD concentration is same, S, right? Now, the BOD is reduced only in the aeration tank. There is no other unit in the activated sludge process that has the capability to remove the BOD. So, if any removal of BOD is happening, that is happening only in the aeration tank. If any BOD removal is taking place, it is only taking place in your aeration tank. So, I will write here, BOD is only removed. BOD is removed only in the aeration tank for the activated sludge process. The secondary sedimentation tank will not remove any BOD. This is S, not S0. This is your S. Secondary sedimentation tank will not remove any BOD, right? Now observe this. The value of Q0 is given to you. What is the value of Q0? Q0 is 47 mld. Then S0 is also given to you. S0 is how much? It is 300 milligram per liter. Then next, the BOD removal efficiency of the aeration tank is 96%. So efficiency for BOD removal is 96%. Next, the volume of the aeration tank is 380 meter cube. So volume is 380 meter cube. Next you have MLSS concentration X. This is equal to how much? This is 890 milligram per liter. 890 milligram per liter. Okay. Now you need to calculate the specific food utilization rate. So what is the formula? So specific food utilization rate U. This is equal to, so U is equal to Q naught into S naught minus S divided by V into X. So this is the formula for calculating the specific food utilization rate, right? Now, in this formula, I know the value of Q naught, I know the value of S naught, I know V, I know X, only S is not there. So how to calculate this S? For calculating this S, I know the percentage removal of BOD inside the aeration tank. So S is equal to S naught into 1 minus efficiency of BOD removal inside the aeration tank. So this is equal to S naught is given to us as 300 into 1 minus 0.96. Just calculate this. So 300 into 1 minus 0.96. So this will be 12 milligram per liter. This is the value of S. Now you know all the values, you can calculate the specific food utilization rate. So specific food utilization rate U is equal to specific food utilization rate U is equal to Q naught, which is given as 47 mld. So 47 into 10 raised power 6 liters, converting liter into meter per second. So this will be 10 raised power minus 3 meter cube per day. Now I have to check this. Okay, so instead of doing this, so 47 into 10 raised power 6 million liters per day multiplied by S naught minus S. So 300 minus 12 divided by volume is 380 meter cube. So 380 into 10 raised power 3, converting meter cube into liters, multiply by MLSS concentration, which is 890 milligram per liter. So this is 890. So this will be your specific food utilization rate. Just go for it. Please calculate this. So this will be 300 minus 12 into 47 into 1000 divided by 380 into 890. So this will be 40.02. This is your specific food utilization rate. 40.02, right? So this is how you need to solve this question. Wherever the efficiency is given to you, there will be some purpose of giving you this efficiency, right? So let's take another question. Try this one. It's a very good question, very good question. Take your time, solve this. Go for it. Let's see this. The question says that the activated sludge process is designed for the secondary treatment of 7500 meter cube per day of municipal wastewater. So first of all, Q naught is given to us as 7500 meter cube per day. Next, after primary clarifier, the BOD ultimate of the influent which enters into activated sludge process reactor is 200 milligram per liter. So S naught is given to you as 200 milligram per liter. This is the amount of BOD which is entering into the activated sludge process reactor. Treated effluent after secondary clarifier is required to have the ultimate BOD of 20 milligram per liter. So BOD which is coming out from the secondary sedimentation tank is 20 milligram per liter. So S is 20 milligram per liter. Mixed liquor volatile suspended solid concentration in the reactor and the underflow is maintained as 3000 milligram per liter and 12,000 milligram per liter. So X is given to you as 3000 milligram per liter and XU is given to you as 12,000 milligram per liter. MLSS concentration in the underflow. Respectively, the hydraulic retention time and the mean cell residence time is 0.2 day and 10 day. So hydraulic retention time HRT 0.2 day and your sludge age or mean cell residence time. I'll write here mean cell residence time. Mean cell residence time or sludge age theta c. This is given to you as 10 days. Now in the question you are asked to calculate the underflow discharge. You need to calculate the wasted sludge discharge QW, right? So first of all, how to calculate this? So theta c is equal to sludge age is equal to V into X divided by QW into XU, right? The amount of organic matter present, amount of MLSS concentration present in the aeration tank divided by the total amount of MLSS concentration leaving the system per day. So the total amount of MLSS concentration leaving the system per day is QW into XU, right? Now just observe this. Do you know the volume of the tank? Volume of the tank is not given to you. But for this volume, you know this discharge Q naught and you know this hydraulic retention time, right? Using these two, you can calculate the volume of the tank. So volume of the tank, volume of the aeration tank, volume of aeration tank, volume of aeration tank is equal to V, which is equal to Q naught into hydraulic retention time. So Q naught is 7500 meter cube per day. So Q naught is 7500 meter cube per day multiplied by the hydraulic retention time, which is 0.2 days. So from here you will get the volume in meter cube. Just do the calculation. 7500 into 0.2. So this will be 1500 meter cube. This is your volume. You know the value of X, you know the value of XU, you can calculate the value of QW. Theta C is already known to you. Substitute the value of theta C, which is 10 days. So theta C is equal to V into X divided by QW into XU. So V is 1500. Please keep a check on the units. 1500 meter cube. So 1500 into 10 raised to power 3. This will be liters. Multiplied by MLSS concentration, which is given to you as how much? 3000 milligram per liter, right? This is 3000 milligram per liter divided by QW that you need to calculate into XU, which is 12,000 milligram per liter, and theta C is given to you as 10 days. So from here you will get the answer in liters per day. Just check in which units you need to report the answer. You need to report the answer in meter cube per day. So accordingly you need to change the units, right? Here you will get the value of QW in liters per day. Just calculate this. So this will be 1500 into 3000 divided by 12. So this will be 37500. QW will be 37500 liters per day. So the same answer in meter cube per day will be QW is equal to 37.5 meter cube per day. This will be your final answer of QW. 37.5 meter cube per day. Just check for this. This is 37.5 meter cube per day, right? So this is how you need to solve this question. So whenever you will get a question from activated sludge process, most of the chances are you will get the question from the basic definitions of the activated sludge process, right? Chalo, moving on with this, try this question. It's a very good question. 2 parts are given to you. In the examination, you got this question for 4 marks. Go for it. I'll give you 2 minutes for one part. Just try for first part. So let's see this. The question is saying that the sludge from the aeration tank of the activated sludge process has the solid content by weight is 2%. This sludge is put in the sludge thickener where the sludge volume is reduced to the half. Assuming that number of solids in the supernatant from the thickener is negligible, the specific gravity of the sludge solid is 2.2 and the density of water is 1000 kg per meter cube. Then what is the density of the sludge that is removed from the aeration tank? Okay. So this is my aeration tank of the activated sludge process. This is the aeration tank of the activated sludge process. From here we collect some amount of sludge. This sludge contains 2% of solids by weight. And then this sludge is taken to the sludge thickeners. This sludge is taken to sludge thickeners. This is your sludge thickeners. Right? Here you have 2% solids by weight. So first of all, let the density of sludge removed from the aeration tank be X. Let X be the density, right? Now, the solid content is 2%, means out of 100% by weight of solid sludge, out of 100% of sludge, out of 100% by weight of sludge, 98% is the weight of water and 2% is the weight of solids. This is by weight. By weight, 100% sludge comprises of 98% weight of water and 2% is the weight of solids. Okay. Now, I have already taken the density of the sludge to be X. So, by equating the total volume, by equating the total volume so volume of the sludge will be 100 by X. X is the density of the sludge. So weight by density is the volume of the sludge. This is equal to volume of water, which is 98 divided by rho W. Okay. Density of water is given to us. Okay. Then density of solids is equal to specific gravity of solids into density of water. I think I am given with the specific gravity of sludge solids and I also know the density of water. So just substitute all these values. So specific gravity is given to you as 2.2 and density of water is 1000 kg per meter cube. So you have this as 100 upon X is equal to 98 divided by 1000 plus 2 divided by 2.2 into 1000. So from this equation you can very easily calculate the density of the sludge. Please go for it. So this will be 98 by 1000 plus 2 divided by 2.2 into 1000. So this will be 1011. So density of the sludge will be 1011.02 kg per meter cube. This is the density of the sludge which is coming out from the aeration tank. It is 1011.02 kg per meter cube, right? This is the solution of your first part. Now just try the second part. Again, I'll give you 2 minutes of time. Just go with the second part. go with the second part. Okay, now the second part is saying what is the solid content by weight of the thickened sludge. So whatever sludge is coming out of the sludge thickening beds, what is the weight content? What is the solid content by weight of that sludge, right? So the sludge which is coming out from this sludge thickeners, if the volume entering is V, if the volume of sludge which is entering into the sludge thickener is V, the volume that is coming out is V by 2, right? Half of the volume is reduced in this sludge thickener. We will going to use this. So volume of sludge entering into sludge thickeners, volume of sludge entering into sludge thickener is equal to 100 divided by the density of the sludge, which is 0.2. 1011.02. 1011.02. This will be your density of the sludge which is entering into the sludge thickener. Sorry, this will be the volume. Please calculate this volume. 100 divided by 1011.02. So this will be 0.0989 meter cube, and this is your volume V, right? Now the volume of sludge coming out, volume of sludge coming out from sludge thickeners is equal to V by 2, which is equal to 0.0989 divided by 2. How much is this? 0.0989 divided by 2. This will be 0.04945. 0.04945 meter cube. So this is the amount of sludge which is coming out of the sludge thickener. Now this reduction in volume happened because of the reduction in the water content. Solid content will not change, right? Solids are not removed. You can see here there is one statement written in the question which says that assuming the number of solids in the supernatant from the thickener is negligible. Means whatever supernatant liquid we are getting from the sludge thickeners, in that the solid content is negligible. So reduction in this volume happened only because of the reduction in the water content. Okay, so this is the volume. So I can write down reduction in volume, of the sludge, reduction in volume of the sludge in sludge thickeners is only due to removal of water, is only due to the removal of water content, right? So this is the total volume of the sludge, right? In this total volume of the sludge that is coming out from the sludge thickener, and in this volume of the sludge, the volume of solids is constant. So volume of solids is equal to volume of solids is equal to 2 divided by 2.2 into 1000. This is the volume of the solids. We have already written this. This is the volume of solids, 2 divided by 2.2 into 1000. So this is the volume of solid which is constant in both the sludge which is entering into the sludge thickener and the sludge which is coming out of the sludge thickener. From here we can calculate the volume of water content or volume of water in the sludge coming out from the sludge thickener, coming out from sludge thickener this is equal to total volume that is coming out from the sludge thickener. This is equal to the total volume coming out of the sludge thickener, which is 0.04945 minus the volume of the solids, which is 2 divided by 2.2 into 1000. So this is the amount of this is the volume of water that is present in the sludge which is coming out from the sludge thickener. Just calculate this. So this will be 2 divided by 2.2 divided by 1000. So 0.04945. So this will be 0.04854 meter cube, right? 0.04854 meter cube. Now can you calculate the weight of water which is present in this much volume of water? So weight of water present in outgoing sludge this is equal to volume of water, which is 0.04854. This is 0.04854 into 1000. 1000 is the density of water. Just do this. So this will be how much? This will be 48.54 kgs. This is the weight of water, right? Next, you can calculate weight of solids. So weight of solids present in outgoing sludge is equal to volume of solid, which is 2 divided by 2.2 into 1000 multiplied by the density of this solids, which is 2.2 into 1000. So this is your weight of solid present in the outgoing sludge, right? Now you can calculate the solid content. So solid content by weight is equal to weight of solid divided by the total weight of sludge, which is 2 plus 48.54. Weight of solid plus weight of water. Chalo, do this. 2 divided by 2 plus 48.54. This will be 0.0395. In percentage, this will be equal to 3.95%. So this is the percentage of solids that are present in the thickened sludge, right? So this is one of the very important question asked for 4 marks. 2 parts are there for this question. Earlier we used to have this common data type question where the data is linked. One answer is linked with the solution of the next question. So until and unless you cannot calculate or you do not know the density of the sludge, you cannot calculate the volume of the sludge. So this is one of the example of linked answer type question, right? So I hope you've got the solution. Chalo, try this question. Go for it. Have 2 minutes of time. Go for it. Please do it. Let's see this. The question is saying that the settling test of the sample drawn from the aeration tank liquor of activated sludge process having MLSS concentration of 2800 milligram per liter was carried out in 1 liter sample. Test yielded the settled volume of 200 ml, right? So you have taken 1 liter of wastewater. In that 1 liter of wastewater, the MLSS concentration was 200 milligram. These 200 milligram of the solids got settled and the volume of this 200 milligram of solids came out as 200 ml. Then what is the value of sludge volume index? So observe this. So sludge volume index is equal to volume of settled solids in ml. Volume of settled solids in ml divided by the weight of settled solids in grams. Volume of settled solids in ml divided by the weight of settled solids in gram. This is your sludge volume index. So volume of the settled solids are 200 ml. So this is 200 divided by the weight of settled solids. So that is 200 milligram, 2800 milligrams. So this will be 2.8 grams. So this will be your sludge volume index in ml per gram. You have taken 1 liter of wastewater. In that 2800 milligram of MLSS concentration was there, right? So this 2800 milligram of MLSS got settled and the volume of this 2800 milligram of MLSS came out to be 200 ml. So this is how you need to calculate the sludge volume index. Calculate this and tell me what is 200 divided by 2.8. So this will be 71.43 ml per gram. So this is your sludge volume index. Okay. Chalo, moving ahead with this question. This is your next question. Try this. It's a good question, right? It's a good question. Try this. I'll give you 3 minutes of time. Just go for it. Let's see this. The question says that a township has to treat 5 lakh liters of water per day. A township has to treat 5 lakh liters of sewage per day, right? Which has 5-day BOD of 150 ppm. So let me write this first. So what is the amount of water that is treated? So Q naught is given to you as 5 lakh liters per day. And this water has BOD 5 of 150 ppm. ppm is nothing but milligram per liter. ppm is nothing but milligram per liter, right? For your wastewater and raw water, not for air pollution. The oxidation pond is used for this purpose. The effluent can have a BOD of 15 ppm. That is, the effluent which is coming out of the oxidation pond can have a BOD of 15 ppm. The loading is 40 kg of 5-day BOD per hectare per day. Loading is how much? Loading is 40 kg of BOD 5, 40 kg of BOD 5 per hectare per day. So this is the amount of BOD that is allowed to be applied over this oxidation pond, right? So this is the organic loading given to you, allowed organic loading given to you. Then the required area of the oxidation pond is by this is the organic loading given to you, means this much amount of BOD you can apply over 1 hectare meter in 1 day. So first thing is you calculate how much amount of BOD needs to be treated. So organic or BOD loading, I'll write this as organic loading or total BOD to be treated, total BOD 5 in 1 day. This is equal to BOD 5, which is 150 milligram per liter multiplied by 5 lakhs. So 150 multiplied by 5 lakhs. This is amount of BOD in milligram that you need to treat in 1 day, right? If you convert this milligram into kgs, so this will be 150 into 5 lakhs divided by 10 raised to power 6. This is the amount of BOD that you need to treat in kgs in one day. So how much it will be? So these are 6 zeros, it cancels out. 15 into 5 is 75. So 75 kg per day of BOD you need to treat in 1 day. The loading, organic loading which is allowed, organic loading which is allowed is how much? Organic loading which is allowed is 40 kg, 40 kg per hectare per day. Means in 1 hectare of the oxidation pond, you can only treat 40 kg of BOD 5. For calculating the area, just divide this total BOD with the organic loading. So total BOD 5 divided by the organic loading. So this is equal to 75 divided by 40, and this will going to give you the area in hectares. Just do this, 75 by 40. This will be 1.875 hectares. And this is the amount of area which is required to treat that much amount of water, right? Chalo, so this was an easy question, only you need to understand the question what is given. Now try this question. Again, a very good question, but this time I'm going to give you only 2 minutes of time. Just go for it. Go for it, do it. Let's see this. The question says that a system of 7 river segments is shown in the schematic diagram. The RIs, QIs and CIs are from I is from 1 to 7 are the river segments that corresponds to the flow rates and the concentration of the conservative pollutants respectively. Assume complete mix at the intersection, no additional water loss or gain in the system. In steady state condition given Q1, Q2, Q4, Q6, C1, C2, C6, what is the steady state concentration of the pollutant in the river segment 7? So these are the river segments given to you. Let me draw these river segments first. So this is one river segment meeting the another river segment here, and they are forming the third river segment. Then R4 is going out and R5 is going ahead. Okay, I'll start like this. So this is your river segment R1 and this is your river segment R2. This is your river segment R1, this is your river segment R2, and they are forming the river segment R3. The discharge Q1 and Q2 is given to you, but Q3 you are not given. You need to calculate the value of Q3. So Q1 is 5 meter cube per second and Q2 is 15 meter cube per second. Q1 is 5 meter cube per second and Q2 is 15 meter cube per second. So the value of Q3 will be Q1 plus Q2 and Q1 plus Q2 will be 5 plus 15, that will be 20. So 5 plus 15, so Q3 will be 20 meter cube per second. Q3 will be 20 meter cube per second, right? Now the concentration of pollutant in river segment 1 and 2 is also given to you. C1 is 8 kg per meter cube and C2 is 12 kg per meter cube. From that we can calculate the concentration of the pollutant in this third river segment. So C1 is 8, C2 is 12. C1 is 8 kg per meter cube and C2 is 12 kg per meter cube. Since both the river segments are added here, so the concentration of the pollutant in this river segment 3 is equal to, so C3 is the weighted average of C1 and C2 with respect to the discharge. So this is equal to C1Q1 plus C2Q2 divided by C1 plus C2 divided by Q1 plus Q2, divided by Q1 plus Q2. Now substitute all the values and get me the value of C3. So C3 is equal to, C1 is how much? C1 is 8, Q1 is 5, C2 is 12, Q2 is 15 divided by 5 plus 15. From here you can calculate the value of C3. Just do this. So this will be 40 plus 8 into 5 is 40 plus 12 into 15 divided by 20. So this will be 11. C3 will be 11 kg per meter cube. Now you observe this. Now from this R3, your river segment R4 is coming out and R5 is also going ahead. So your river segment R4 is going out. Your river segment R4 is going out and R5 is moving ahead. So this is your river segment R4 and this is your river segment R5, right? Now you are given with the discharge of Q4, which is 3 meter cube per second. Discharge Q4 is 3 meter cube per second. Discharge Q3 you have already calculated, which is 20 meter cube per second. So discharge Q5 is equal to Q3 minus Q4. So this is equal to Q3 is 20, 20 minus 3 will be 17. So Q5 will be 17 meter cube per second. This will be your Q5. Okay. Now here is a catch in this question. It was asked this year in GATE 23. What is the catch in this question? The catch here in this question is, when any segment splits out from the river, the concentration of the pollutant will not change, right? Most of the student, they have subtracted this concentration. If here the concentration is C1, here concentration is C2, here concentration is C3, then concentration in segment 4, C4 will be equal to C3, and concentration in segment 5, C5 will be also equal to C3. The concentration of the pollutant will not change if any segment separates out. Only it will change if any addition is taking place. So concentration C5 is again equal to C3. So concentration C5 is equal to C3, and this C3 we have already calculated as 11 kg per meter cube. Okay, now let's see further. You have river segment 6 getting added, which is forming the river segment 7. So river segment 6 is getting added. Here river segment 6 is getting added, which is forming the river segment 7. So here you will have river segment 6 and this is river segment 7. The discharge for river segment 6 is given to you as 8 meter cube per second. Okay. Discharge for river segment 6 is given to you as 8 meter cube per second. Discharge for river segment 5, we have already calculated, this is 17 meter cube per second. So you can calculate discharge for river segment 7, which is Q5 plus Q6. So this is equal to 17 plus 8. So discharge in river segment 7 is equal to 25 meter cube per second. This is your discharge in your river segment 7. It is 25 meter cube per second. Now, I need to calculate the concentration of the pollutant in river segment 7. For that, the concentration of pollutant in segment 6 is given to you as 10 kg per meter cube. Concentration of pollutant in river segment 6 is given to you as 10 kg per meter cube. Concentration of pollutant in segment 5 is again equal to 11 kg per meter cube. So again, by taking the weighted average, since any stream is getting added, therefore the concentration of the pollutant is changing. If any stream is getting out from the segment, then concentration of the pollutant does not change. Now, the concentration of the pollutant in segment 7, so C7 is the weighted average of the pollutant concentration. So C7 is equals to C6 into Q6 plus C5 into Q5 divided by Q5 plus Q6. So C7 is equal to C6 is 10 and Q6 is 8. This is 10 into 8 plus C5 is 11 and Q5 is 17 divided by 17 plus 8. This will going to give you the concentration of the pollutant in the river segment 7 which is asked. Please calculate this and tell me the answer. So 80 plus 11 into 17 divided by 25. So this will be 10.68. kg per meter cube. Please cross check if we have made any mistake or not. So this is correct, this is correct. Yeah, 17, this is 20. Yeah. Yeah, this is absolutely correct, right? So this is how you need to solve this question. It was asked this year only. Again, a very important category of the question. So please observe this. Observe the details what we have discussed in the question. If any river segment is getting added, right, then only the concentration of the pollutant will change. If any river segment is moving out, then there will be no change in the pollutant concentration, but the discharge may change. Discharge will definitely change. Chalo, moving on with this, try this question. This is question from the solid waste management. Go for it. I'll give you 3 minutes of time. It's a very, very good question. Just go for it. Please go for it. I'll give you 3 minutes of time. Just go for it. It's a very good question from solid waste management. Thank you, Richa. Thank you so much. You also try this question. Though you have already done your masters, but you can also try this question. I can expect one answer from you also. Chalo, go for it. Try to solve it. Try to solve it. The same variety of question was asked this year for 2 marks. There are very limited areas in your solid waste management and air pollution from where questions can be framed. And I have trying to cover all the important areas from where we are seeing regular questions in the examination. This is one such area. This is from the proximate analysis for solid waste, in which moisture content is defined as weight of moisture divided by the total weight. Okay. The definition for moisture content in solid waste management is weight of water divided by the total weight. Now let's check this question. Question says that the moisture content of the solid waste collected from the city was found to be 12%. I'll write down everything. Moisture content. Moisture content 1 was found to be 12%. This is from the solid waste collected from the city. Composting technique is used by the waste handling facility of the city. Composting technique is used by the waste handling facility of the city to biodegrade solid waste. If the required moisture content for composting technique is 48%, calculate the amount of water to be added in 60 metric ton of solid waste. Okay. It is 12%. This moisture content has to be increased to 48%. Then the question is simply asking, tell me how much amount of water to be added in 60 tons of solid waste. So initial weight of solid waste is 60 tons. In 60 tons of the solid waste, how much water to be added to increase the moisture content from 12% to 48%? I think that's a very, very easy question. Okay. You have very clearly understood what is asked in the question. 60 tons of solid waste given to you. For this 60 tons of solid waste, the initial moisture content is 12%. You have to increase this moisture content from 12% to 48%. For increasing this moisture content, how much amount of water you need to add, that is asked in the question. Now let's see how this is a more of aptitude question than being a technical question. Let's see this. So initial weight of solid waste is 60 tons. So weight of, or the initial weight of water, initial weight of water, initial weight of water is equal to 12% of 60. This is your initial weight of water. Just calculate this. 12% of 60. What is 12% of 60? This will be 7.2 tons. So the initial weight of water is 7.2 tons. From here, can you calculate weight of solids? Weight of solids is equal to total weight 60 minus weight of water, which is 7.2. So total weight 60 minus 7.2, this will be 52.8 tons. This will be 52.8 tons, right? I hope everything is clear till now. Initial weight is 60. In this 60 tons, 7.2 ton is water and 52.8 ton is your solids, right? Now, the moisture content is increased to 48%. And when you are increasing the moisture content, you are adding some quantity of water, means you are increasing the weight of water, but weight of solids will be constant. Weight of solids is not either increasing or decreasing, it is constant as it is. So, for increasing the moisture content, you are only adding some water, right? So, weight of solids will be constants. So, let me say that let the new weight of solid waste, be x tons per day, right? Now, out of this x tons, 48% is the weight of water. So, I can write this: final weight of water is 48% of x, So, this will be 0.48x. This is the final weight of water. This is 0.48x. This is my final weight of water. Now, I have the final weight of water. I have the final weight of solid waste. So, can I write x, which is the final weight of solid waste, is equal to weight of water, which is 0.48x, plus the weight of solids. So, weight of solids is 52.8 tons. Since weight of solid is not changing, weight of solid is constant. Weight of solids is constant. Weight of solids is constant. From here, you can get the value of x. Do it. So, 1 minus 0.48. So, 52.8 divided by answer. This will be 101.54. X will be 101.54 tons. This is your new weight of solid waste. Now, in this new weight of solid waste, you can calculate the weight of water, which will be 0.48 times of x. So, new weight of water is 0.48 times of x, which is 0.48 times of 101.54. This is the new weight of water and this will be in tons. So, 101.54 into 0.48. This will be 48.74 tons. 48.74 tons. Now, this is the final weight of water. You know the initial weight of water. You can calculate the amount of water to be added. So, amount of water to be added is equal to final weight of water minus initial weight of water. Final weight of water minus initial weight of water. Minus initial weight of water. So, final weight of water is 48.74 minus initial weight of water, which is 7.2 tons. So, this much amount of water in tons you need to add in 60 tons of solid waste to increase the moisture content from 12% to 48%. So, 48.74 minus 7.2 tons. So, this will be 41.54 tons. This much amount of water you need to add to increase the moisture content from 12% to 48%. Okay. So, this is how you need to deal with this question. Chalo, let's move ahead. Let's see this question. This is a question from the energy content. My dear students, whenever you need to calculate the energy content, the first thing that you need to do is, let us assume the total weight of the solid waste as 1 kg. Now here in this question, different components of the solid waste are given to you. The percentage by mass of this components are 20%, 45%, 5%, 10%, 20% like this. And energy content on the discarded basis is given to you in megajoule per kg. You need to calculate energy content of the solid waste on the dry basis, right? So let's solve this question. So 1, 2, 3, 4, 5. So here you have components. Here have percentage mass. Here you have mass. Then you have energy content. On discarded basis in megajoule per kg. And here you calculate the energy content. Okay, let's see this. So one by one, first have food, paper, cardboard, plastic and others. This is food, paper, cardboard, plastic and others. This is the component given to you. Percentage by mass is 20, 45, 5. 20, 45, 5 and then this is 10 and next is 20. Energy content on discarded basis is 4.5, 16, 14, 32. 4.5, 16, 14, 32. 4.5, 16, 14, 32 and 8. Last one is 8. Okay. So this is the data given to you. You need to calculate energy content on the dry basis. My dear students, whenever you need to calculate the energy content from the solid waste, first thing is calculate energy content on the discarded basis. Here you are given the energy content, right? I'll explain you everything step by step. Just observe this very carefully. First of all, whenever you see this data, where the percentage by mass composition of the component is given to you, first thing you do is, let us assume the total weight of the solid waste is 1 kg. Let us assume total weight of solid waste total weight of solid waste is 1 kg. If total weight of solid waste is 1 kg, then in 1 kg of this solid waste, 0.2 kg is food waste, 0.45 kg is your paper waste, 0.05 kg is your cardboard waste, 0.1 kg is your plastic waste, and 0.2 kg is your other waste, right? So if 1 kg is the total weight of the solid waste, then the weight of food will be 0.2 kgs. The weight of paper waste will be 0.45 kgs. The weight of cardboard waste will be 0.05 kgs. The weight of plastic waste will be 0.1 kg. And the weight of other waste will be 0.2 kg, right? So when you add this, you will get the total weight of solid waste is 1 kg. Now this column says that if you burn only 1 kg of food waste, you will get 4.5 megajoule of energy. But right now, how much you are burning? You are burning only 0.2 kg, right? Again, I'll explain you this. This column tells me that if I take this value of 4.5, this tells me that if you burn only 1 kg of the food waste, the total energy released will be 4.5 megajoule. Then by burning 0.2 kg of the food waste, energy released will be 0.2 into 4.5. This is the energy released by burning 0.2 kg of the food waste. Similarly, by burning 0.45 kg of paper waste, the amount of energy released will be 0.45 multiplied by 16. 0.45 multiplied by 16. Similarly, by burning 0.05 kg of cardboard waste, the amount of energy released will be 0.05 into 14. Then similarly for plastic waste, by burning 0.1 kg of plastic waste, the amount of energy released is 0.1 into 32. And for other waste, by burning 0.2 kg, the amount of energy released is 0.2 into 8. So this is the total energy released by the solid waste on discarded basis. So this is your energy content on discarded basis. Just calculate this. This will be how much? 0.2 into 4.5. This will be 0.9 megajoule. This will be how much? 0.45 into 16. This will be 7.2 megajoule. This is how much? This is 0.05 into 14. This will be 0.7 megajoule. This is 0.1 into 32. So this will be 3.2 megajoule. This will be 1.6 megajoule. Now this is the energy released, right? When you will add all these energies, you will get the total energy released by the solid waste by burning 1 kg of it. So just add all of them. So 0.9 plus 7.2 plus 0.7 plus 3.2 plus 1.6. So this will be 13.6 megajoule. This will be 13.6 megajoule by burning 1 kg of the solid waste, right? So I will write down energy content of solid waste on discarded basis is 13.6 megajoule per kg. This is 13.6 megajoule per kg. Now we need to calculate energy content on the dry basis. So energy content on dry basis is equal to energy content on discarded basis into 100 divided by 100 minus moisture content percentage, right? So this is your energy content on your dry basis. So for calculating energy content on dry basis, again you need to know energy content on discarded basis. So just get the value of moisture content. It is also given to you. Moisture content is given to you as 26%. So substitute the value in percentage. So energy content on discarded basis is 13.6 multiplied by 100 divided by 100 minus 26. So this is your energy content on dry basis. Do it. 13.6 into 100 divided by 100 minus 26. So this will be 18.3938. 18.38 megajoule per kg. This is my final answer. This is your energy content on the dry basis, right? This is how you need to calculate it. First of all, assume the total weight of the solid waste as 1 kg and then consider all the individual components. Okay, chalo, moving ahead. You can take this. This is again the same variety of question. You can just solve this. Again an aptitude based question. You can just take the screenshot for this. Let's move ahead. Now this is one of the very important category of the question, right? Every year we are observing question from this category in civil engineering examination and also in the examination of environmental engineering. That is the second paper. The question says that a sample of air is analyzed at 25 degrees Celsius at 1 atmosphere pressure is reported to contain 0.03 ppm of CO2. The equivalent CO2 concentration in microgram per meter cube will be, okay. Now simply the concentration is given in ppm. You need to convert this in microgram per meter cube. This is one of the very important concept in your air pollution, right? So conversion of ppm into microgram per meter cube. Okay. First of all, my dear students, I would like to tell you, at standard temperature and pressure, at STP, what is standard temperature? Standard temperature, I'll name this as T1, is 0 degrees Celsius or 273 Kelvin. And standard pressure P1 is 1 atmosphere. At standard temperature and pressure, 1 mole of the gas occupies 22.7 liters. At standard temperature and pressure, 1 mole of the gas, 22.4 liters. Okay. Just attempt this question. Give me just 1 second. At STP, 1 mole of the gas occupies 22.4 liters. 1 mole of gas occupies 22.4 liters, right? Means the volume V1 can be taken as 22.4 liters. Now my dear, here the gas is not present at STP, it is present at 25 degrees Celsius. So first of all, we need to calculate how much amount of volume is occupied by the gas at 25 degrees Celsius. For that, I'll go with ideal gas equation. By ideal gas equation, PV by T is constant. So I will write down P1 V1 by T1. This is for the standard temperature and pressure. Should be equal to P2 V2 by T2. So first one is for standard temperature and pressure and second one is for the existing condition. This is at STP and this is at existing condition. Existing condition, right? So in the existing condition, pressure is given to us as 1 atmosphere. Pressure is 1 atmosphere. Temperature is 25 degrees Celsius. We need to convert this temperature into your Kelvin scale. Substitute the values. So P1 is 1 atmosphere. V1 is 22.4 liters. T1 is 273 Kelvin is equal to P2 is again 1 atmosphere. V2 I need to calculate divided by T2, which is 273 plus 25. From here you need to calculate the V2. Do it. So this is 273 plus 25 divided by 273 into 22.4. So 24.45. V2 comes out as V2 comes out as 24.45 liters. So I can say that at 25 degrees Celsius and 1 atmosphere pressure, and at 1 atmosphere pressure, 1 mole of CO2 is given to us. CO2 is the gas. 1 mole of CO2 occupies 24.45 liters. 1 mole of CO2 occupies 24.45 liters, right? Now just calculate the molecular weight of CO2. Carbon is 12, oxygen is 16 into 2. So 16 into 2 plus 12 will be 44. So 44 grams of CO2, 44 grams of CO2 occupies 24.45 liters. So can I calculate the weight of 1 liter of CO2? So 1 liter of CO2 weighs 44 divided by 24.45 grams, right? So can I calculate 1 meter cube of weight of 1 meter cube of CO2? So weight of 1 meter cube of CO2 is 44 divided by 24.45 into 10 raised to power 3 grams. This is the weight of 1 meter cube of CO2, right? Please observe this. This is the weight of 1 meter cube of CO2. This is the weight of 1 meter cube of CO2. If 1 liter of CO2 is weighing this much, then 1 meter cube of CO2 is weighing this much, right? Now observe this. What do you mean by 1 ppm of CO2? 1 ppm of CO2 means 1 meter cube of CO2 is mixed with 10 raised power 6 meter cube of air. 1 meter cube of CO2 is mixed in 10 raised power 6 meter cube of air. Now you can just take the weight of 1 meter cube of CO2. So here you have already calculated the weight of 1 meter cube of CO2, which is 44 by 24.45 into 10 raised power 3. So this is equal to 44 by 24.45 into 10 raised power 3. This is the weight of 1 meter cube of CO2 divided by 10 raised power 6 meter cube of air, right? So this is how your 1 ppm of CO2 looks like in gram per meter cube. So 1 ppm of CO2 is equal to 44 by 24.45 into 10 raised power 3. Now this 10 raised power 6 in gram will be microgram per meter cube. This will be microgram per meter cube. So this is the weight of, or this is the concentration of ppm in microgram per meter cube. But in the question it is given that, the concentration of CO2 is 0.03 ppm, not 1 ppm. So 0.03 ppm of CO2 is equal to 0.03 into 44 divided by 24.45 into 1000 microgram per meter cube. So from here you will get the concentration of ppm of CO2 into microgram per meter cube of CO2. Just do this. So this will be 0.03 into 44 into 1000 divided by 24.45. So this will be 53.98 or 99 microgram per meter cube. A very important concept and a very important numerical. So 0.03 ppm of CO2 is equal to 53.99 microgram per meter cube in concentration. Again, a very, very important concept, right? So this concept you should never ever forget if you are going for the GATE examination. This is again a very important concept. Chalo, moving ahead. This is one of the question. You can take the screenshot, you can try for it. You can take this as an homework question. Chalo. This is again a question from waste to energy plant. Again, these are very simple questions, right? You can just take the screenshot for it. Let's move ahead with the last question. This is our very last question for the day. The question says that which of the following parameters is not used to determine the air quality index? Okay, so first of all, my dear students, you should always remember what are the different parameters which are used to calculate the air quality index. So I have the list for you. So the air quality index is determined by taking the consideration of PM10, PM2.5, carbon monoxide, ozone, NO2, SO2, NH3 and lead. These are the only parameters which are used to calculate the air quality index. In this, you will not see anywhere the use of CO2. So CO2 is not used for calculating air quality index. CO2 is not used for calculating air quality index. For calculating air quality index, right? Please mark this, very important exam question, very important interview question. So CO2 is not used for calculating air quality index. So for this question, your option B is your correct option, right? So this is our last question for the day. I hope you have got enough information for revising the content of environmental engineering in just a very short span of time. My sincere request to you, again go through all these questions. These are very, very important questions whose chances of coming in the examination are very high. Go through all these questions to revise your concepts. Chalo, moving ahead, I have to make few announcements again. So, you can join our Telegram group to get the regular updates for all the job vacancies, for enjoying the daily technical quizzes, and also for getting the update of our YouTube series. The link is given in the description box, so you can just click that and join our Telegram group. We at IMS Gate Academy provide you with classroom program, online, offline, both hybrid program and the self-learning program, in which we provide you with more than 800 hours of live teaching with interaction and doubt solving. We provide you with 30 plus theory and exercise book, where in our exercise book the questions are well versed in level 1, level 2 and level 3. We provide you with more than 130 plus online tests, where we provide you with chapter test, subject test, multiple subject test, advanced subject test and the full length mock test along with the video solution. We provide you with 12 one-to-one mentoring sessions. These are personalized mentoring sessions for the students to keep them motivated and stay focused in the hectic journey of 8 to 9 months of GATE examination. So this is all, my dear students. I hope you have enjoyed all the 3 sessions of environmental engineering. Please share with your friends and stay tuned to our IMS Gate Academy YouTube platform. Tomorrow I'll be coming up with the next session, a very interesting session of structural analysis. So join me live on the same YouTube platform of IMS Gate Academy from 6 p.m. onwards. So this is all for today. Have a very great night ahead. Thank you so much for listening patiently.